In the last video, we showed that the variables x and y are independent for this distribution. Now let's find the variance of the random variable x, the variance of the random variable y, and the variance of the sum of the random variables x and y. Let's recall that the expected value of x, or in other words, the mean of the random variable x is 3.5, for y it's 6.8, and for the sum, x plus y, it is 10.3. In order to find the variance for x, we will find the difference between each value and the mean. We'll square that and then multiply it by its probability. So for the x value 2, we have a mean of 3.5 and a probability of 0.25. And then we'll add to that for the x value 4. The mean for x is 3.5, square that, and then multiply it by the probability that x is 4, so 0.75. And that variance turns out to be 0.75. Now let's do the same for y. And the variance for y turns out to be 1.92. Now let's find the variance for the sum of the variables x and y. And that will be then the sum, 2 plus 5, minus the mean, 10.3, squared, times the probability for that entry, 0.08. Then move to the next pair. 2 plus 6 minus the mean, 10.3, squared times that probability, 0.03. Then we'll move through the table for each of those possible sums until we get down to the last, 4 plus 8 minus the mean, 10.3, squared times that probability, 0.42. And we'll find that variance to be 2.67. Now we will note that this is equal to the sum of these two variances. So in other words, in this case, when x and y are independent, and this is an important qualification here. When x and y are independent, the variance of x plus the variance of y will be equal to the variance of x plus y.